Hello, Cross Riverians. The best school has come to stay in the city of Calabar. It is called Beryl International School. Take advantage of this opportunity now.
Tell me the best school, Beryl is the best. Tell me the best school.
Okay, sorry about what just happened. Okay, look at this diagram I was trying to show you before the camera fell. Okay, look up. Now, if you look at these two diagrams, the first diagram here shows that 3 tubes are inserted in a bath of water, and whereas 3 tubes as well are also inserted in a bath containing mercury instead of water. Now, if you look at, we are trying to explain capillarity actions anyway. Now, if you look at the tube that the bath that contains water, first of all, the smaller the diameter, the level at which capillarity is felt compared to when the diameter is increased a little and then when it's further increased. Now, if you look at the first tube here, because the diameter is very small, it's the smallest, what happens? The capillarity of water rises up to the brim of the tube. But when you further increase the diameter of the tube, it drops to this point. And when you now further increase the diameter of the tube, what happens? The level of water drops further again. Now, this is what happens when the water flows through the different tubes. Now, that will be compared with mercury. If we replace the liquid with mercury instead of water, what happens is this. Now, the tube that is smallest in diameter, which when we use it for water, actually absorbed so much of water, now is deficient of mercury within it. You see it? Also, now, when we now increase the diameter of the second tube a little, what happened? The mercury level came up a bit to this point. And then when the diameter of the tube is further increased, that is as in the case of the third tube now, the water level also increased further. So what was responsible? That for water, when you increase the capillarity, the water level falls instead of increasing. But for mercury, when you increase the capillarity, the water level increases in the tube instead of falling. Now, there are 2 forces that are involved, and I'm going to be dealing with those 2 forces now. This is just to demonstrate to you and to show you what happens when you use mercury or when you use water. Now, 2 forces are involved. The first force that is involved is called adhesion. Alright, the second force that is involved is called cohesion. Now, there's adhesion, there's cohesion. Now, if we add adhesion, cohesion, and surface tension, causes the capillarity, that is the rise and fall of fluids. The rise and fall of tubes. These are responsible, whether you call it surface tension, you call it the cohesive force, or the adhesive force. Now, the cohesive force is the force that attracts, the force that is active between a substance of the same kind. That's 2 substances of the same kind. The force that acts between them, just like water, is called cohesion. But the force that acts between 2 different substances, 2 substances of different material, is called adhesion. It's called adhesion. I'll take that, we'll write it on the board, don't worry. But the force that acts on water is cohesive force. Whereas the force that acts on the mercury and the tube, the glass tube, is adhesion. The force that acts on the water and the tube, that's the glass tube, is cohesion. Okay, watch this. Okay, now I'll define capillary action. Capillarity, or you call it, or capillary action is capillarity or capillary action is the tendency of liquids, or let's say fluids. Okay, let's say liquids to rise or fall in a narrow tube. Explain it. Capillarity or capillary action is the tendency of liquids to rise or fall in a narrow tube. That's the definition of capillarity. And you saw it in the diagram where in case of water, the liquid rises the way the diameter is. The smaller the diameter of the tube, the higher the level of the liquid in the tube, particularly water. Whereas when we now replace water with mercury, the smaller the diameter, the lower or possibly lowest the level of mercury in that tube. And I told you that three forces are involved. We have explained one, which we said is the surface tension, but the other two are what I'm going to explain now. Where's my duster? Okay, now we have defined capillarity. Now the other two forces I told you responsible for the capillary, that is the rise and fall of liquid in tubes, are one, let's define them, cohesion. Cohesion. What is cohesion? This is a force acting between two molecules of the same kind, e.g. water molecules. Water molecules, that's cohesion, is a force that acts between two molecules of the same kind. The force that acts between two molecules of the same kind. Whereas adhesion, this is the force that acts between two molecules of different kinds, e.g. example of those molecules is let's say example of those molecules, e.g. have water and glass. Same it, water and glass. So the force of attraction between two molecules of the same kind is called cohesion, whereas the force of attraction between two molecules of different kinds is adhesion. So you know the cohesive, or you call it cohesion, or cohesive force, adhesive force, or the force of cohesion, or the force of adhesion. Now, the surface tension is also a force. Cohesion is a force. Adhesion is a force. These are the forces that are responsible, I told you earlier, for the capillary action we explained just now, or we have seen the diagram presented to you. They are the ones that are responsible. Okay? I think we'll end the class here. We will not move further. But in our next class, we'll deal with similarities and differences between viscosity and friction, in order not to bug you with too much of explanation. Is that clear? Okay, but before I go, I'll give an assignment. The first assignment I want you to find out for me. Now, if you critically look at what we're explaining with those diagrams, the mercury itself did not rise in the capillary tube that has the smallest diameter. Well, as you increase the diameter, it was coming up gradually, and as you further increase the diameter, it was coming up also. It further increases. That's the level of mercury in the tube with the largest diameter. Okay? Now, it shows that if you pour a liquid, particularly water, on the floor, let's say on this floor, it will flow and spread evenly. But if you pour some quantity of mercury on the floor, what happens? Even if it's a drop, let's begin with a drop, it will fold itself, forming droplets, we call it goblets, like a ball on the floor. It shows that the force binding the molecules of mercury together is stronger than the force binding the molecule of mercury and the floor. Whereas water will flow and spread around, shows that the force binding the water molecules together is weak compared to the force between the floor and the molecules of water. Do you get that? I needed to make you understand that. So why is it that? Explain. Why mercury does not wet glass, but water does. Is that clear? Explain why mercury does not wet glass, but water does. 2. Also explain why water rises in the stem of plants. These are simple assignments for you. Exactly. So I just need nothing much. Explain why mercury does not wet glass, but water does. Explain why water rises in the stem of plants. So do have a nice time. I'll see you in our next class and then trash out all the assignments I have given so far. Take care.